Hello, I'm Aiden Petropoulos. My teammates are Jackie Villanueva and Joey Raphael. This is the ESEN 404 Virtual Project Showcase. We are Team 28, the Power Outage Education app. Our sponsor is Dr. Mladen Kazunovich, and our TA is Swarnba Roy.
Thank you, Aiden. So I'm Jackie Villanueva, and the problem that our project focuses on is that people are often uninformed about the best course of actions to take before and during a power outage. This lack of knowledge can result in a lack of preparation and uninformed decision-making that can cause further harm. For example, the lack of knowledge in generator safety or not having a shelter in mind before a power outage can cause some issues. So our solution is to develop an app that provides different age-specific knowledge about power outages by using engaging interactive apps. These engaging apps include using games that will teach students about power outages and how they may be mitigated and how to best prepare for them.
Here we have our integrated system diagram in which users will install the app and be led directly into the hub app. And based on their age group, they'll select the respective app for the respective age group. So if they're kindergarten and 5th grade, they'll interact with the elementary school game. If they're 6th to 8th graders, they'll interact with the middle school game. And if they're 9th to 12th graders, they'll interact with the high school learning app. And from then on, the app will record their test score data, their learning outcomes, and their learning progress. And if users wish to select back, they can go back to the Help app and try out the other respective apps in the application.
Thank you, Joey. As I said, I'm Aiden Petropoulos. I was in charge of creating the game meant for kindergarten through 5th graders, and I designed it on Unity. Some design features were that it was compatible with PC and Android devices as a whole app. However, if the school district or the kid had a iPad, they could run this game individually on an iOS device, not through the whole app though. Second, that I designed an interactive map that mirrors the real-world Doceum. So for those who don't know, the Doceum is a kids museum based in San Antonio that runs a kindergarten and preschool program out of it. So the kids can take their iPads and go throughout the museum and find these clues like they would in the actual game. Next is that I integrated pre and post quizzes for data collection. What this means is that the kids would take a pre-test, play the game, and then take a post-test, and then we would see if the game was effective in increasing their knowledge of what to do during power outages. The results for that will come later. Next is that I built a node-based clue system. So that means that there are 8 clues in total scattered throughout the game in each of the different towns that the Doceum has. And each game or each clue has an individual ID tag. And once that ID tag is solved, it can't be solved again. So they can't keep just solving the same answer and then having, 8 out of 8 clues that way. It also means that I built a score system for it. So if they got the question right on their first try, they'd get 100 points. If they got it right on their second, third, fourth, however many other tries, they would get 50 points. So that also helps the teacher understand, okay, say the kid got 400, that means they got every question wrong on the first try. But if they got 800 and they found all 8 clues, that means they got each question right on the first try. Down in the bottom right is a picture of what the clues or questions might look like. So there's a power outage, a transmission line down. So then what happens when too many people use electricity during a heat wave? It makes the power line stronger. If they guessed that the first time, it would be 50 points, and then their clues in the top picture would go 1 out of 8, and their score would be 50 out of, or just 50. And then if they got it right on the first try, it'd be 100. The quiz keeps going until it keeps prompting them to ask again or try again until they get the question right. In the top, that's just a picture of Littletown, one of the scenes in all of the game.
Hi, my name is Joey Raphael. I'm the developer for the middle school subsystem, and essentially I develop a Unity game targeted towards middle school students. The main features being that it's compatible with PC and internet devices. There's an integrated quizzing system. I implemented the A-star algorithm to make sure there's automated wire pathfinding, and overall the game is a grid building system with a Tycoon style game in which players are expected to connect generators to buildings in order to win the game. And with that, there's a quizzing system that encourages players to learn about power outage mitigation measures in order to further learn.
Thank you, Joey. So once again, I'm Jackie Villanueva. I was responsible for developing the Flutter base that will navigate to the elementary and middle school games, in addition to developing the high school lesson. The high school lesson is structured that there is an outage scenario, there is the causes of power outages, some mitigation measures, and what to do during a power outage. Some of these screens can be found on the right side of the slide, including the main hub page, and then a page talking about the causes of power outages. The goal is to teach high school students about the impact of power outages, how to best adjust, what to expect during an outage, and how to best prepare. So the integrated system was put onto a Moto G Pure for testing. What testing including was running through each lesson, including the elementary, the middle school, and high school lesson in one instance, and then navigating back to the main page. How this entire app, all three subsystems were integrated was by using Flutter's in-app web view, which I will explain further in the next slide. As I mentioned, the in-app web view package from Flutter was used for integration for specifically the elementary and middle school lesson. Since the elementary and middle school lessons were developed on Unity, what was done was that they were put onto URLs, which will then be opened up onto the Flutter app. So what the code itself does is that it checks the platform, it has extra tools for debugging, and then it sets the landscape orientation to best experience the games. Finally, it opens the itch.io page, which then opens up the Unity games. So some integrated system results from testing includes that the app was able to load, the FPS was well within specifications, including the touch input delay. The app was generally found to be very stable, there was no crashing that ever occurred during testing, and that it was possible to navigate to the games and then back to the hub. However, as seen with the high school app, there is still some UI inconsistency. While the integrated system functions as intended on the Moto G phone, the UI is cropped on smaller devices. However, the app otherwise passes all other specifications of the app. This is further shown in the system validation plan, where we tested the app functionality, subsystem objective completion, UI consistency, offline and online functionality, performance, Flutter and Unity, and learning outcomes. It was found that the app generally passed all tests except for the UI inconsistency. The app performed within specifications, and the learning outcomes was measured positively. Finally, this is the GitHub for a power outage page, and thank you so much for your time.